Hi, my name is Qasim Raza. I am a network software engineer at Lumina Networks, and today I'll be talking about Leap 3.0. Leap is the Lumina extension and adaptation platform, and this is its third major release, and I'll be guiding you through the features added. So what is Leap? Leap is an extension platform to the Open Daylight SDN controller. Through this, Leap adds a microservice message bus, which allows additional services and applications to be mounted on to the Open Daylight controller. Applications such as a CLI engine, Lumina Service Mapper, and other useful features that enhance the feature set of the controller. So we'll be taking a look at a very specific use case today. We're going to look at designing an API to perform end-to-end service creation across a heterogeneous network. So we'll be looking at a total, I'll be giving an overview of 5 components, and then we'll be talking about the 2 components added in this release. So the first one is being able to model any API with Yang models in Leap. The component that does that is WAL. WAL stands for Workflow Abstraction Layer. So given any Yang models, and we'll see examples of that later, we can link these Yang models and CRUD operations to workflows, which will then be implemented in our second component, which is the workflow engine. Workflow engine uses the Camunda open source automation platform to implement the API, divide workflows into tasks, allowing for more modular design, and these tasks stitch together other components in the framework. Some other components used are LSM, which stands for Lumina Service Mapper, which translates structured Yang payloads for various vendor models. There is another video on the channel available that delves more into that. Napalm, which uses the open source Napalm framework for CLI device interaction, and a new service added called distributed tracing, which helps with debugging and tracing of requests over microservices. So we'll start with our first component, which is a workflow API layer. So Workflow API layer, also known as WAL, provides an interface between LSC REST northbound and the workflow engine. This allows any service or RPC to be modeled in Yang. These WAL endpoints can be model any operation implemented in workflow engine, including models that aren't available on vendor devices currently. So an example of that is the IETF L3 VPN service model. Another great use of this is you can provide netconf-like properties to CLI devices. So you can interact with your CLI device with some sort of structured API. So an example of this on the left-hand side without WAL is a more RPC execution format, where you describe in the payload what your operation is, along with the other payload details that you need to provide. But with WAL, you can embed the operation you want to do inside the URL, and then interact with your WAL endpoint as if it was a CRUD operation that you are performing on the network, similar to how netconf works. Our next component is workflow engine. So workflow engine is a Camunda BPM processing engine, which allows us to create workflows, decision models, and then allow users to execute these workflow tasks. The modeling notation is known as BPMN. It's a global standard for workflow modeling. and we'll see examples of these components like start, stop event, tasks, and gateways in the next section. So this is a sample of workflow. This workflow is just a generic use of components. It doesn't really do anything per se. As you can see, the tasks are just placeholders. So this shows different ways you can stitch together workflows and these different tasks. Keep in mind these tasks are behave like modules or libraries in code, and you can reuse these tasks as long as you maintain the inputs and outputs, as long as you use the inputs and outputs the same way. So this is an example of a network workflow that we've implemented. So if we start on the left, that's a start. That's a start point. Then we're asking it to trigger a script task, and that we've called check VLANs. So it'll check what VLANs are programmed. Does the VLAN whichever VLAN we're looking for, does it exist? If not, it terminates the workflow. If yes, it follows the other path and creates an L2 VPN config on our device. So the general process of developing a workflow is to generate the BPMN in the Commando modeler, get the basic definition going, and that's what you see on the right. It also provides some validation. Then the next step is to write these script tasks. So the components like check VLAN and put L2 VPN are our script tasks. These can be implemented in Python, Java, or Groovy. They can be tested individually, and these are the ones that become reused. And then finally, once the workflow is written, you can add it, you can upload it to the workflow engine and then test it using Postman or curl. The final feature added to Leap 3.0 is distributed tracing. Distributed tracing is the process of tracking the activity resulting from a request to an application. So you make a request on the northbound, it travels through several different microservices, and you want to be able to trace that path. You want to see how long it's spent in each path and where there are potential bottlenecks arising. So in Leap 3.0, this is achieved using open tracing, which is an open source project used in various cloud-based deployments. This instruments JSON RPC and the workflow infrastructure. So if you, let's say, have a workflow that interacts with a database, that will register in open tracing, and that'll be available to be visualized in the Jaeger UI. This is what the Jaeger UI looks like. So you can follow the trace of operations. It can go to, so from LSC to workflow engine, then back to LSC, then maybe then perhaps Napalm. So it depends entirely on what the workflow is and what it implements. Thank you very much for your time.